Alright, the stream. So I'm going to try to pull up that chat so that I can see you guys and your questions. And again, I'll change the title of this video. You can finally pay attention. Good to know, Mateo. Inattention is half the battle. I don't know what the other half is, but I know for sure that that's half. Okay, so I've given myself a scratch piece of graph to work with, or sorry, not graph, assignment to work with. Alfredo. Were you making Alfredo from scratch, or did you have the pre-made stuff? That's always the important question. That's awesome, Mateo. I love cooking. Okay. Anyone else that's here, go ahead and just kind of type in and just say that you're here. Let me know what question specifically you want to look at. I'll go through any questions you guys have. I already finished the other review that I started earlier tonight. So what I'll do is after we're done with this video, I'll save that completed solutions to all the classes so that you all have access to them. Yes, Mateo, we can go ahead and do number 10. One thing I wanted to try a little differently with this stream, you guys will look above, I have both sets of formulas for the parabola right there, as well as how they look in each one. And then even further up, you have the equation of the circle. So hopefully this will be a little more useful than just me kind of saying it out loud. You guys can kind of see, hey, this is where Mr. T got his information. I hope you guys can see that. At least on my end, when I have the video set to full screen, I'm able to see it. I can read it fairly decently. Like, the words at the top are a little pixelated, but they're they're not hard to make out per se. But yeah, just let me know if you guys have any questions. I did do my best with this. Okay. So, Mateo, sorry, I had to move some stuff around. Number 10, because we're dealing with a parabola of the x squared variety, that means our parabola hypothetically should be going up or down. First thing we should find is our vertex. Our vertex is at 1, 2. The next thing we should try to do is find our p-value. So remember, you always take whatever number is there in front of the parentheses and say 4p equals -16. So then, dividing both sides by 4, you'll find that p equals -4. So now, going with the formulas that we need, we're going to go ahead and find our focus, which is going to be, for this set of varieties, we're going to notice that we're going to be looking at these equations here. So the equations there are going to be h, k plus p. So that's going to be 1, 2 minus 4, which will equal 1, -2. So there's our focus. Now our directrix is going to be the other equation. That is going to be y equals k minus p. So y equals 2 minus -4. And so then y equals 2 plus 4. see the vertex. Angie, what do you mean by see? There's no C value in here. Unless you're talking about the center, but there's no center in a vertex. Okay. Yeah, we can do 14 afterwards. So back to this, Mateo. Y equals 6 is our directrix. So if you remember, again, that y equals 6 is a horizontal line that goes through 6 on the y-axis. That's what we're going to graph. 1, 2, 3, 4, 5, 6. There's our directrix. Our focus is at 1, 2. Sorry, 1, -2. Our vertex is at 1, 2. I meant to do a different color for that one. Now, really quick, before I actually graph this, I don't have an apartment. Anyways, one thing to do before you start graphing this, make sure that your answer makes sense. The directrix is a line, so that means it's going to be of the form y equals or x equals. So your directrix is either going to go this way or it's going to go this way. Okay? So it's going to be one number. It's not going to be a point. A point is an ordered pair. It's going to be one number. Okay. So again, what I was trying to say was that double check your work. Make sure this makes sense. Your p-value was 4. Even though it said -4, it's still telling me that the distance between my focus and vertex is 4. That works out. What about my directrix and my vertex? 1, 2, 3, 4. It works too. So that makes sense. So now, again, remember that your vertex is going to go away. Sorry, your parabola is going to go away from the directrix. Or if you remember it as it goes towards the focus. I don't like that one. I'm going to fix that one. Oh my gosh, I can't graph. Oh my goodness. Not going well tonight. Ugh. This is what happens when you do 2 math classes in one night. So there we go. That is our graph of our parabola, the coordinate of our focus, and the equation of our directrix. We're going to go ahead and do 14 next, and then we're going to go ahead and do number 20. Hopefully you guys are okay with that. Trick question, you don't have a choice. So yes, we're going to go ahead and do 14, 20, and 16. So let's jump to 14 first. So on 14, I'm given the focus of 4, 6, and the directrix is of y equals -6. You all have to make sure you remember what this line looks like, because if you draw it the wrong way, you're going to get the wrong equation altogether. Y equals -6 goes up and down. Now, one thing to kind of help you guys with this is if you know that your directrix is going up and down, it's going to be pointing at these equations. Those red lines are going up and down. Those are your directrixes. I don't know how you'd say the plural form, but those are the directrixes. So y equals -6. We're going to go ahead and graph that. 1, 2, 3, 4. I can count 3, 4, 5, 6. Oh wow, Mr. T made a mistake. Guys, be careful. I just finished saying y equals, and I meant to say it goes this way. Tired. So yeah, y equals goes through that way. So y equals -6. 3, 4, 5, 6. So that's this line here. Okay. And then the focus, key phrase, focus, 4, 6. So 1, 2, 3, 4, 6. Okay, now I'm going to label these because I want to make sure you guys understand this. I was thinking ahead. The vertex is going to always be found halfway between the directrix and the focus. What you guys need to remember is that you're not saying, oh, it's going to be halfway this way, it's going to be halfway this way. That's not what we're doing. It's always halfway, either vertically or horizontally, whichever the orientation is. So I want to find halfway between the line and the point here, which we can count it out if we need to. That total length was 12, so half of 12 is 6. So that means I'm going to end up right here. So that right there is the vertex. That coordinate is 4, 0. That 4, 0 is my h and my k. Now, to make sure we're on the right track, the parabola has the p-value of 6 because we counted how far it was to get to here. That was 6 units. But now the question is p going to be a positive 6 or a negative 6? Well, the parabola is pointing up. Well, how do you know it's pointing up, Mr. T? Because the parabola always goes away from the directrix. So that means p is positive. If you take a look at the little chart here, straight up, the graph where it says p is greater than 0, that means p is positive. And it matches the direction of our graph. So I've got p, I have my h and k. Let's go to the equation. Now, if you're still confused as to which equation you need to use, just match the drawing. We're dealing with the one pointing up, so that means it's going to be of the form of x minus h. So x minus h squared equals 4p times y minus k. No, Mateo, you're not getting a birthday pass on your test tomorrow. Angie, yes, if you choose to not use your note card, I will grant extra credit, okay? But, you know, make sure that you really want to go through with it, because halfway through, I'm not going to let you decide, oh, I actually really need that note card. Okay, it's all or nothing. You got to go for it or don't go for it at all. So here we go. H and k. X minus 4 squared equals 4 times 6, y minus 0. Yes, there is still an extra credit problem on the test, so you will still have that opportunity to earn it if you want. Okay, so now the x minus 4 does not simplify. The 6 times 4 is 24. Now, if you ever have a 0, like inside of there, I need you to simplify it so that it's just the variable. So in this case, it's going to be 24y. So there's our equation. Let's see here, we did 14. Now, since we're on this page, let's go ahead and go to 16, and then we'll jump to 20. So on 16, I need to put the equation of the circle in standard form. So standard form means I need it to look like x minus h, 4, 0. It's halfway. There's my focus. There's my directrix. The vertex is halfway between the two. I just added some new pens and I forgot to change the thickness of the pens. Alright, cool. No magic, all math. Okay, so on this one here, this is the one that I was telling you all you need to do the completing the square method. You're going to be doing it twice. So I'm going to have the x's be blue, the y's be red. This is where we add in that space that goes along with the completing the square. So here we go. X squared minus 6x plus my blank space. Now let's go with the y's. Plus y squared plus 2y plus another blank equals -1. Now because I have two blanks on my left, I'm going to have the same blanks on the right. So plus the blank from the x variable plus a blank from the y variable. So off over here on their little sandbox, we're going to go ahead and complete the square. I'm always looking for the middle number with both variables. So I'm looking at the -6 and the +2. How do you know to complete the square or not? This is not, okay, so right now this equation is set up with a bunch of x squareds, y squareds, x's, and y's. They're mixed variables. Our goal is to get to this. This is our goal. We have to get to this format of the equation. So if you're not in that format, you have to complete the square. There's no other way of doing that. So then over here, we're going to take half of the -6. I meant to do that with blue. So -6 divided by 2 squared. That's going to be -3 squared, which is going to equal 9. So the open spaces, we're going to plug in what we're completing the square for. So that first one, the blue one, goes with the 9 here, and this 9 here. The reason we're completing the square, I don't remember if I told you guys this, is that every time you complete the square, these terms will always factor perfectly. They're going to become some quantity squared. And I showed you all the shortcut for how to go from here straight to the factored form. We divide by 2, Alan, because that is actually the process, the rule. What do you mean by again? We only divided by 2 the first time. -6 divided by 2. We only divided by 2 once. So then the next part of completing the square, working at the blue highlighted equation, that's going to be 2 divided by 2 squared. So 1 squared, which is just 1. So we're going to go ahead and add 1 to both sides, plus 1, plus 1. So now we've done the hardest part of the work. We've filled in the gaps. Now, some of you might think, Mr. T, I don't know what to do, which is fine. Okay, Mateo, you can't say I'm lost. You have to ask a specific question, okay? I can't help if you just say I'm lost because I'm not in front of you, so I can't see your work. At this part, we have to factor. Where are you getting a 1/2 from? That's a -6. Maybe this will help though. Follow the highlighted numbers. I always take half of the middle number, then square it. Your screen is blurry. I have the stream right here, and it's not blurry on my end. Try refreshing your page, Mateo. That might help. Okay, I'm going to try to go on. It looked like one. Okay. If you memorize all the formulas, you don't need the note card. You can take the whole test without it, get extra points on there. If you want the note card for a security blanket, that's fine. I don't care. Okay, so anyways, back to here. We're going to factor this. This blue set of numbers are going to be factored into a perfect square trinomial. Now, the trick I told you all was that middle number of 6, you always take half of it. So half of negative 6 is negative 3. So that means inside my parentheses, I'm going to have an x minus 3. If you want to factor this by hand, you're more than welcome to. I'm just telling you, you're going to do a lot more work. You would do the little x factor trick that I showed you guys in class. The 9 goes on top. The negative 6 goes down below. You're saying, why do we, or sorry, what numbers multiply to make 9 but add to negative 6? Well, that would be minus 3 and minus 3. So technically this becomes x minus 3 times x minus 3, which is the same thing as x minus 3 squared. Essentially, we're skipping all that work. That's why this is why we're doing this, Alan. We're skipping all that work so that you can go straight to the factor. That's all you have to do. I'm going to erase that for a second. Actually, no, I'll keep it up if you need to see it still. But you really shouldn't need that, because I'm trying to minimize the amount of work you need to do. So then down here, you're going to say plus. This also factors perfectly. Since my variable here is y, it's going to be y. My middle number is a positive 2. Take half of positive 2, positive 1. Why do you have to use that? Well, Alan, that's what I'm saying, is that you don't have to do the x thing. I showed you where it came from. I'm not saying you have to do that every time. I'm showing you, you can go straight from up here. You can go straight from here to here every time. Oh my gosh, why is OneNote being stupid right now? Okay, so then that's going to equal this entire thing added together, which is just going to be 9. Now, some of you might be tempted to do more work than you need to. The question says, put the equation of the circle in standard form. This is our standard form. This entire thing right here. Now the second part of the question says, give the radius. So I take a look at my number here. Okay, good. I take a look at my number here. That is r squared. R squared is 9. Well, if we take the square root of both sides, my radius is going to be 3. So there, I've answered both questions now. You get 9 because on the right side, negative 1 plus 9 plus 1. That gets you 9. Okay. Hopefully I answered that question for 16. Let's go ahead and take a look at number 20. Yeah, you want to make sure you add those correctly, okay? Just promise me you guys will do that, okay? Because I promise you that's an easy point to miss out on, and this test is only 50 points. So that means every point is worth 2%. So I'm not doing half points on this test. Number 20. If you did your homework on 11.2 through 3, this question will look awfully familiar. And I encourage you guys to draw what you're given. Any of these equations you can always draw. Now for this one, we're told that the vertex is at the origin. We're told that the focus is at 0, negative 6. And we're told that the directrix is at y equals negative 10. So let's draw a graph. My vertex is at 0, 0. I'm going to label that. My focus is at 0, negative 6. So I know that that's going to be somewhere down here. Doesn't have to be perfect. There's my focus. Now my directrix says y equals negative 10. So y equals negative 10 means it's actually going to be further down. It's going to be much further than, let's use yellow, than the focus. Now, have we ever drawn a graph of a parabola that has the focus and the directrix on the same side? No, we've never done it. And if you look above at our different examples, there's no way that that would ever give a parabola. Okay, because one of two things will happen. Either the the parabola goes away from the directrix, but then I don't contain the focus. Or I go towards the focus, but wait, I cross the directrix. This is not possible. So therefore we would say here that Katie is correct. And then we would say that the focus and directrix cannot be on the same side of the vertex. What did it mean? Which one are you talking about, Alan? Are you talking about for 17? I'm going to assume so since you asked about 17. You're very close, Alan. The only thing I don't see in your work... Well, okay, so alright, so check this out, Alan. The x squareds you partially have correct. You just have to be careful because you changed the sign on 4x. You're not subtracting 4x from anything. You're not doing any of that. You're just rearranging it. So this plus that's in front of the 4x is going to stay there. So it's going to be x squared plus 4x. And then you're blank, just like you said. Yeah, you got to put the plus the blank because that's actually important. The y one, you got rid of your 8y. It disappeared somehow. So for that one, it's going to be plus y squared minus 8y plus another blank. And that's going to equal 5. So that's how the setup should be. Oh, you forgot to type it. Okay, so why don't you try to finish that one up then, Alan? But yeah, don't switch the signs on those. Don't do that. The only times we ever switch signs on anything work-wise is if I say identify the vertex or the center. Those are your H and K's. H and K's are the ones where we change the signs. Those are the only times. No other time. Cool. Not that I'm trying to scold you, but I don't want you guys to make that mistake on that test. Okay. 8:29. We got about a little close to a half hour left, so if there are any more questions, gladly take them, or if we need to finish 17, we can go ahead and do so. I'd just rather like to have Alan try it on his own, see that he gets it. Okay. So 15. How can we determine just by looking at the equation? And 13. Yeah, we can do both. So on 15, if you understand what it means by an equation of a parabola, let's just draw one. We're asking what happens when the parabola is not in the origin. I'm going to challenge you to think the opposite. What happens when the parabola is at the origin? What happens? Well, can we agree that the origin has a coordinate of 0, 0? Hopefully you said yes. So in either equation that you use for the parabola, let's just say we use the x minus h1. It actually doesn't matter what our p-value is for this, because what's happening here is since our vertex is 0, 0, h and k are also 0, 0. And if you all remember what I told you happens inside here, that should be a good indicator to say, oh, x minus 0 is just x. So therefore, x squared equals 4p, nothing happens to it. Y minus 0 just becomes y. So when the equation of a parabola is at the origin, nothing is happening with our equation. We have just a plain old x squared. We have just a plain old y. That's kind of boring. It's kind of bland. There's no parentheses. There's no shifts. So realistically, that's what we're looking for. If you know that an equation, I can just make one up here. X minus 2 squared equals, let's just say 4 y plus 1. I know for a fact that because I have the inside with numbers, I know that these equations are not going to be at the origin. Have Haley email me. She needs to talk to me, not to you, Alan. So this equation here is not at the origin because the h and k are not 0. I just made something up. I just made up a number just to show you guys, well, because there's a shift, it's not at the origin. I just made it up. Now I'm going to challenge you guys to think, well, what if I'm not at the origin? Let's say you're anywhere else on the x-axis. Let's say you're at this point here. I'm going to pretend this is negative 5, 0. Well, in this case, my h is the negative 5, but my k value is 0. So if a point, or sorry, if the vertex is on the x-axis, the k value is going to be 0. Likewise, if I take a look at a point, let's use light blue, that's on the y-axis, let's say it's up here. Let's say that this point is 4. My bad, that's a 0, 4. Well, in this case, h is 0, k is a number. So if a vertex is on the y-axis, then h is 0. Just some things to consider, because I could throw any one of those 3 scenarios your way. I could say, how can you tell if a equation or the vertex is not at the origin, or if it's on the y-axis or the x-axis? I'm not going to be mean and say something like, oh, how do you know if it's going to be in the first quadrant, second quadrant? Like, I'm not going to get that complex. Not that crazy. At least not right now. Alyssa had a question. We're going to do number 13 next, y'all. Okay. So Alyssa, hopefully you plotted these. 2, negative 3 is your vertex. So 2, 1, 2, 3, 2, negative 3. Now I'm going to label this with a little v to remind me this is the vertex. And then my directrix is x equals 7. So then x equals 7, 6. Okay, so it turns out that it goes off the graph, which is fine. It only went off by 1. Now here's the deal, Alyssa. I gave you a vertex, and I gave you the directrix. That's all you need. I don't need the focus. Some of you might be wondering, well, Mr. T, aren't we supposed to plot the focus? Only if the directions say so. The directions for these say, write the equation that represents this information. So if I don't need the focus and I'm not given it, there's no reason to plot it. All I need is my vertex, and with the help of my directrix here, I'm going to find my p-value by counting how many spaces it is between the two. In this case, it's 1, 2, 3, 4, 5. So p equals 5. However, Alyssa, I don't know if p is going to be positive or negative yet. And that all depends on the shape of your graph. If you take a look above me, you'll see the different equations. Now, since my vertex is right there, it has to go away from the directrix. So in the picture that's literally right here above me, that's sort of what's happening. My directrix is that red line. The parabola is pointing, nope, wrong way, this way. So that means that since it's pointing to the left, p is actually a negative 5. So, using the value of p equals negative 5, and my vertex, because that's h and that's k, I can now write my equation. But now, you got to make sure you're using the right equation. We already determined that we're using these sets of graphs, so that means we go to the very top there where it says horizontal, and boom, there's your equation. Y minus k squared equals 4p x minus h. And this is where you all have to be very careful. The h and k have switched positions because the x and y have switched positions. So that means that I'm going to have y plus 3 squared equals 4 times negative 5 x minus 2. So then we have y plus 3 squared equals negative 20 x minus 2. And that right there, Alyssa, is your equation. I have to be careful because I actually trimmed the window a bit here on my end of the video editor so that I can make the little cheat sheet fit on the screen. Now it's crazy because on my end everything looks picture clear. On the YouTube end, when I try to do a full screen, I can still read it, but it's kind of a little blurry, so I apologize wholeheartedly for that. Maybe I'll do this in a coffee bean instead. The only problem is, again, then I have all that background noise. Okay. I had a lot of questions from Alan and Angie. Had one from Alyssa. Actually, I think I had a couple. Well, in the other stream I had the other Alyssa asking questions too. If you guys don't have any other questions, then I can go to sleep early. Yay. But you guys gotta let me know. 18. Yes, I can go ahead and do 18. Yeah. I'm gonna answer Sam's question right now. Oh no, Kasher got the fever. You kids need to stop getting sick. Okay. Alright. Sorry about that, Alyssa. So right here, because your equation has just a plain old y and a plain old x, that should automatically be a big hint to say, hey, h and k are both going to be 0. K goes with y, h goes with x. Now, if you're confused as to why this is true, we can kind of reverse engineer the problem, because the form is supposed to look like y minus 0 squared equals negative 20 x minus 0. So with this, we know h and k are 0. We need to solve for p in order to get the focus and directrix. So right here, we're going to go ahead and say that for p equals negative 20. So dividing both sides by 4, p is going to equal negative 5. So then we use our equations. And actually, I'm going to make sure I write down my work. Since the equation is of the y squared variety, that means my formula is going to be h plus p comma k. So therefore, we're going to have 0 minus 5 comma 0. Negative 5 comma 0. Now here, we're going to go ahead and find the directrix. Now, under that column of the y squared portion, we're going to be doing the x equals equation. So x equals h minus p. And I'm going to show all my work so that you all can see where I get my numbers from. So I have 0 minus negative 5. The first minus is from the actual equation. The second minus is from the fact that p is a negative 5. So therefore, x equals 5. And that goes right here. And that's all you have to do. No graphing for this one, just identify the parts. So hopefully that was helpful to you, Alyssa. I hope so. Just in case you're all curious about how to do 19, it's the same idea. My h is going to be right here. H equals 4, k equals 1. You're welcome. So 4 comma 1 is my vertex. 8 I'm going to set equal to 4p. So therefore p equals 2. So then back to our equations. Since this one is of the x squared variety, that means that my equation will be h comma k plus p. So I'm going to have 4 comma 1 plus 2. Yes, Alyssa, I can go ahead and do number 8. So right here, this is going to be 4 comma 3. Last, but most certainly not least, our directrix is going to be of the variety y equals k minus p. If you guys are curious to make sure whether you're doing something right or not, just make sure, obviously you're checking the columns, but right here, k plus p, let me try a different highlighter, k plus p and k minus p are opposites of each other. So I know that I'm on the right track. I'm not mixing up my equations. So y equals 1 minus 2. Therefore, y equals negative 1. And that's how we do 19. Let's see here. Number 8. Alyssa, we're going to go ahead and do that. Man, look at all this work, y'all. Alright, graphing a circle. And then I'm going to give the center and the radius. Okay, I don't need to do any work here. I have the equation given to me. I just have to remember, where do I find my center? Well, at the very top of my window here, in the equation of a circle's part, we have x minus h. Sorry, had to make sure I could actually read that. X minus h, y minus k. So, h equals 1, k equals negative 2. My iPad is being weird. Hold on. Okay. Now, the other thing I need is my radius, which I'm going to find from looking at this number. And in my general form, it tells me that this is r squared. So r squared equals 16, which therefore means that r equals 4. And that's because you take the square root of both sides there. R equals 4. My center is 1 comma negative 2. Now the graphing part should be the easiest part. We're going to plot our center of 1 comma negative 2. Now because my radius is 4, that means that I'm going to have the same distance left, right, up, and down, and in all directions have a length of 4. So I'm going to go from that center, count 1, 2, 3, 4, place a dot there. That's my first point. Do the same thing going up. 1, 2, 3, 4. That is my next point. 1, 2, 3, 4. There we go. Last but not least, we're going to go down. We're going down. I'm yelling timber. Okay, too soon. Now we're just going to go ahead and connect that. And again, your circles don't have to be perfect. You're not using a compass. And there we go. That is our graph of the circle. Maybe we should nickname it an amoeba. And I have my center and my radius labeled. Hopefully that helped out, Alyssa. I can go ahead and do the next one while we're waiting for a bit. So on this one, my h is going to equal negative 4. Now because y is by itself, that means there's no k value. So k is actually going to equal 0. So my center is negative 4, comma 0. So just plotting that, 1, 2, 3, 4. There's my center of my circle. Now if I take a look over here, r squared is equal to 4. So taking the square root, r is going to equal 2. So now we're going to go ahead and plot 2 to the left, 2 to the right, 2 up, and 2 down. So then we have our circle. right here. Any other questions, my little critters? Just let me know. Hope you're all enjoying your Sunday and weekend. Happy Mother's Day to your mothers. And I apologize if any of you don't have your mothers with you. I didn't get to see my mother today. She's down in San Diego. But I did call her and wished her a happy Mother's Day. I also have my best friend's mother. Lives up here in Thousand Oaks with me. Not with me, but in Thousand Oaks. So I wished her a happy Mother's Day as well. Okay. We have 6 people watching. So I'm hoping any of you have questions. And don't be shy. Don't be shy, guys. Mario joke. We've done a lot. We did do a lot of work. Always that awkward moment of silence. Okay, it says here we only have 3 people watching now, so if you guys don't have questions in the next, let's say, in the next 3 minutes, I'll go ahead and end the stream so that you guys can hopefully go to sleep, or maybe you can work on other homework. And I could sure use some sleep. How do you know which numbers are X, Y, or H and K for number 2? Alright, good question, Alyssa. So on number 2, you have the center. Now center automatically should be a big indicator that your numbers there are H and K. So then when you're plugging into your equation to solve for r squared, that means that these numbers here are x and y. So let's actually go ahead and do this one. I'm going to start with the standard form of the circle, the equation, x minus h squared plus y minus k squared equals r squared. Now I know h and k, so that's x minus 0 squared plus y minus 3 squared equals r squared. Now I'm going to take this equation here, and I'm going to go ahead and do some work off to the side here to get r. So that means for x and for y, I'm going to substitute in the 3 and 7. You do not change your signs here, you just plug them straight in. So right here we, oh, my bad. We have x, oh, sorry, 3 minus 0 squared plus 7 minus 3 squared equals r squared. 3 minus 0 is just 3. 7 minus 3 is just 4. So 3 squared plus 4 squared. This should look somewhat familiar. 25 is going to be r squared. So once we have the value of r squared, just go back here. Just plug it in. Now I'm going to not cheat a little. I don't want to say cheat. I'm going to simplify this x minus 0. And that's going to be just x. So let's use a different color, blue. So x squared plus y minus 3 squared equals 25. Now Alyssa, do you know what you're going to do for questions that ask you something like numbers 4 or 5? Because if you don't know how to do those, I'm down to redo those problems for you to help you out. It's always fun waiting for that delay. And then there were two people watching the stream. 3 people, I guess. Now, if you're still watching, I might be nice and give you a hint as to what your extra credit question is. Just saying, might give you a hint. But then it wouldn't be fair, because then this video goes public. And then anyone who watches it later all the way to the end. But that assumes they watch it through to the end. So Alyssa, was that helpful to you, or? Hopefully it was. Let me know if you want me to do numbers 4 or 5, because I can do those for you to make sure you know how to do those types of problems. Where do you find these notes online? In a bit, Daniel, once I'm done with this stream, I'm going to go on OneNote, and I'm going to go ahead and send this, not file. I'm going to replace all of the files that say Unit 11 review with the one that I already have completed. So this one right here that I've already done for period 5 was the one I did on my earlier stream. We didn't do the whole thing, but we essentially I completed the entire thing after we finished. So I'm going to re-upload that to all the other classes so that you can see it. Because right now your period 4, you're not seeing any of this if you're looking at it from your period 4 link in your classroom. Yeah, so this is your classroom. If I look in period 5s, I have the entire thing done. No, you don't have to download the app. So if you go into Google Classroom and you click on the left side where it says Notes link or Class Notes, I think it's Class Notes, then the link will open this file. You just have to click on Unit 11 Review. That's all you have to do, and you can view all of this stuff straight from your computer. But no, you don't have to download any sorts of files or any programs. But yeah, essentially I did all the problems already, so if you're coming late to the stream, you could always just watch it again. I think you can jump to different sections too. Alright, so if you're still here, which I kind of wish I could see who's still here actually, because all it tells me is there are 4 people watching. I can't actually see who's watching. I'm going to give y'all a hint for what your extra credit question is. It's going to look awfully similar to example 4 from your notes. We didn't do a lot of this in the review packet. So if you kind of study what we did on that, that's going to be your, essentially this will be your extra credit question. Not this one exactly, but this type of problem. And with this one, you're only completing the square once. You don't have to do anything to the variable that does not have the square. Now, because it is extra credit, I'm not going to work through it with you. I'm going to let you guys kind of try to figure that one out. At this point, if there are no other questions, I'd like to call it a night, as I'm sure some of you would like to do as well. Because let's be honest, the struggle is real. When is the struggle never real? When my Microsoft OneNote decides, okay, I think I'm getting it to work. How do you know if you do it twice or once completing the square? In a question like down here, what we did earlier tonight, Alyssa, both the x and the y have a variable squared. So since there's an x squared and y squared, you're going to complete the square twice. In the example that I showed you in the notes, there's only one variable being squared, only the y in this case. So because only the y is squared, you're only going to complete the square once. Now I am going to give you guys sort of a little hint here. If you only have to complete the square once, your function is going to be a parabola. If you have to complete the square twice, your function is going to be a circle. And you guys are not at the level of the conics that hypothetically you'll be at next year. You have much more things to worry about with when you deal with hyperbolas and ellipses. So those have different rules. But for now, those are the only two we're looking at. We're only looking at circles and parabolas. Alright, so at this point, I'm going to go ahead and end the stream. I'm going to call it a night. If you guys have additional questions, don't hesitate to bug me tomorrow morning. Usually I'll have like 3 or 4 people in there, but you're more than welcome to all come in. Brunch, lunch are also good. I can't help after school because I'm coaching football, but just let me know if you guys need help, okay? Take care.